Hi, this session will see how to work with the PrimeTime tool. So before starting with the PrimeTime, let's see what are the data setup that we need to have. So I am currently in PrimeTime directory. Then I'll just show you what are the required files. Now we are going to do this PrimeTime analysis after synthesis, logic synthesis. So we will be having a gate level netlist, and then we require a constraint file which was given to the logic synthesis, and we need to have the target library, so which we have targeted for the logic synthesis. So with this we can start with the prime time analysis. This is just a timing analysis tool which will tell you about whether your design timing has been met or not. So what you've done, like in design compiler report underscore timing, it is given the report. The same thing can be viewed over here. In addition to that, we have the flexibility to modify our netlist, in a sense that not physically we are going to change the cells and all, but what modification can we add to the netlist so that it will be optimized for the time. So that's what we are going to see now. To invoke prime time, we use the command pt underscore shell. So we can work with both GUI as well as in command prompt. So we are going to see both. So in command prompt, we can start with setting up the library. So I'm just showing the location where the library is there. Okay. So now it's loaded. Then I need to read the netlist. So here it's a Verilog netlist. Read underscore Verilog. Johnson underscore count underscore DC dot v. So it's showing 1, that means it has read it. And then next we need to source the SGC file using source command. Let me see. So I sorted out that error, and now we'll source this. Sourcing is done. Now I am invoking in GUI. So now you can able to see right clicking, new schematic. So this is a counter design, so with 8 registers, so it's an 8-bit counter. Okay, so to analyze, we'll straight away start with the report timing. So timing, report timing. So there is no changes that we can make. By default let it be as such. And then you can see, so report timing, and you can able to see pricing edge of the clock, and then clock network delay propagated, and then slack has been met in this case 41.212. But we will see whether the setup and hold time requirement has been met or not. So to see that, go to timing, histogram, endpoint slack. So you have maximum setup violations or minimum setup violations that you can able to see from which pin to which pin it has happened. So now the delay type is maximum, and then I'm just giving OK. So now you can see, so there is no problem with the maximum endpoint slack, and now let's see the minimum. So now there is a problem in worst case setup time. You can able to see here it's showing in red, so that means the slack is negative in this case. Okay, so it's showing the slack versus the number of paths. So in this path, in this register path, there is a timing violation. So now to see that, we can right click on any particular node and then inspector for the worst path selected pin. So now we can inspect it, and then you can show that the slack is violated. Alright, so we can able to see that analysis in the waveform with respect to the latency, and we can also see the schematic also. Fine. So from which register to which register there is a lag is happening. Now to solve this problem, what we need to do? So go to the schematic, and then you can find the ECO, and then there is an option called insert buffer. So here from this, now you understand why we added the target library. So we are going to add the buffer cells. So based on the area and then driving resistance, you can choose it. So now in this case I am choosing ANDA buffer X2, so the driving strength is true, and then I am just giving OK. So close this, and even you can close this also. And now in the prime time, again I am coming to the timing histogram, and then endpoint slack. We had a problem with minimum, and give OK. Would you like to update timing? Yes, because the modification which we made, right? So the design is not timed or timing is not validated. So just give OK. So now it got reduced. Now on that particular register net, it has inserted a buffer. Now you can able to see the change, right? It's moved from 8 to 7. Now you can again go to this inspector, worst part to the selected pin. Again there is a violation, and then going to the schematic, and then you can double click on this, and then you can able to see the buffer, right, got inserted over here, and then inverted. Okay, fine. So you can go to the schematic and then see. Now to make the job little easier, I'm just choosing all the register path, and then going to the schematic, ECO, then I'm adding the buffer, and then giving OK. Then again timing, endpoint slack, minimum, OK. So now this problem has been solved. Now you can see it's now the slack is positive. Right click, inspect it to the selected pin. Then now you can see the slack has been met, right? And then move to the schematic, and then if you just zoom out, you can see the buffers are inserted. Okay, right? So the buffers are inserted. Now it has met with your timing. So now before we'll close this, we have to do very important step. So as I told, this tool doesn't go and modify anything on your netlist. So whatever the report that has been given by the primetime tool, so we need to write it in the separate file. So write is a command. You can do it in the GUI mode. Changes -format space text file we are going to write, then output ECO. Okay, it's not right. It's right, underscore changes. Done. Right, it's showing one. So now to see this, we'll now close this. Now I just open the schematic before I close. So now you can able to see how the buffers are inserted, right? So based on the primetime analysis tool, now the buffers are inserted over here. Okay. And I'm just exiting. Come back. And now you can find the ECO file is written. You can use gedit. And then we'll see what is there. So changes list formatted as text. So it is telling insert buffer in top, add one AO buff x2, right, from which register the name. So this information will be taken to your IC compiler. So this will be helpful when you are doing clock tree synthesis also. So this information will be taken. That means I need to insert buffers to meet my timing there. So it will make little job easier. That's why ECO is all about engineering change order. So how to smart I am doing this compilation, and at each and every step I am making a smarter compilation which will help the next abstraction level to finish the job little earlier. So if I not do this step, then I don't know, already there is a problem in that particular part where I require drivers like buffers or inverters, right? So if I don't do this, then I need to spend more time there in CTS to solve my problem, right? So that's all with respect to primetime. I just given only the basics. It's a very vast topic. Use a user guide and then try to understand few more things. I'm just given a basic stuff, so you can practice this. Maybe in the theory class we'll take it up one session in the next week, and then we'll see some more constraints, effective constraints in primetime analysis and the reporting options. I've not done much on reporting, only the basics on reporting, so that we will do it in the theory class. Okay then, see you.